Launch a heavy satellite deep into the space until its distance becomes from the center of the earth becomes double, and then watch is the crushing grip of gravity on the satellite weakens dramatically and the gravitational potential energy shifts to the brand new state or not. So this is what we are going to see in this question, that what happens to the force of gravity and the potential energy when you take a satellite from a surface of earth to that point where its distance is double of the radius of the earth. So first of all, I'm going to show you the the visual gravitational field lines. These are the field lines which show us the strength of the gravity of the planet. So if a planet is a larger in size, then there will be more lines we have to show, we have to depict more lines. So anyways, this is the visual representation of the gravity of the planet, and all the field lines are towards the center, showing us that the Earth or the planet pulls any object, even if it's satellite or anything, towards its center. So right now, this is a radius of the Earth, and the satellite was initially at the surface, which we where we have taken it to that point where its distance is 2r. So dear students, this is a new position of the satellite, and I'm just for a reference, I'm going to show you the orbit of the satellite at that point, and this is a orbit. Now, speed will be obviously changed, time period will change. When it was orbiting very close to the Earth, it will have a different time period. What is the weight? What is the force of gravity right at that point? With what force the Earth is still pulling it towards the center? That's what we have to calculate. So let's find it. So the weight is actually the pull of the Earth, and the weight is that's why the according to the Newton's law of gravitation, this is equals to the g. Big M is the mass of the planet, small m is the mass of the satellite, divided by the r square. R is the orbital distance. Now in this equation, this gm over r square is showing us the gravitational field strength. That's why we usually write the weight like this equation as well. Anyways, we are going to use this equation. So the weight is equals to mass of the planet have not changed, neither the satellite, divided by distance is 2r, is basically 2 big R and take its square. So this is going to become gmm over 4r square, and that you can write it like this, 1 over 4 into. So students, this is a weight. This is a new force of gravity at that point, and you can see it is 0.25 times the force of gravity, or 0.25 times the weight of the satellite at close to the surface of the Earth. So that's why we should select 0.25 W, and this is a force that was applied by the Earth on the satellite when it was close. Now, let's talk about the gravitational potential energy. And the interesting part of this video is that I am going to show you the graph as well. So don't skip the video. Now, when the satellite is orbiting, it will have a certain speed at that point. It will have a total energy, it will have a kinetic energy as well as potential energy. Now, the potential energy, EP, is equals to the negative gmm over small r. Now, dear students, why it is negative? Because of the attraction. Because you have to deliver the energy to the satellite to move it away from the Earth. That's why it's negative. So you have to addition the energy into the system in order to take it away. So all the attractive forces are negative. So, anyways, I'm going to right here the capital R when it was close to the surface of the Earth, and the new potential energy when it will be at that point will be gmm over 2r. So you can see that it has become one half of the previous amount of energy, which means that it has become a less negative than initially. What does it mean? It means that less negative means that actually the potential energy has increased, because if you take a difference of the energy between these 2 points, it will be positive, which shows the energy has increased. Dear students, it is not asked, but I'm just showing you for the reference. And its answer is positive, okay, because I have subtracted the final minus initial. So you can see that this is an energy that has been increased. Anyways, now I'm going to show you quickly the graph. Okay, so dear students, at that point, it is maximum negative, which is at a surface of Earth, negative GMM over R. So this always follow this pattern, and you see that as the distance is increasing, it is becoming less negative. So at a distance 2R, it is zero point 0.5 times EP. And then further, you can see how it is decreasing. So it means that this is obviously, this should be the right answer. So right answer is option C, which is 0.25 W and 0.50 EP.